Okay, so very first thing they're looking at in section 3, still talking about functions as we're going through this, and it talks about intervals where you have increasing, decreasing, or constant. And for those different parts, that's where they're going to tie in the function or the interval notation you were talking about. That basically, when you get to this part of it, if it's increasing, the graph is going to rise from the left to the right. If it's decreasing, the graph falls from the left to the right. And if it's constant, well, there's no fall. It doesn't increase, it doesn't decrease. It's basically just a horizontal line. Okay, and the biggest thing, and this goes back to when they talk about interval notation, that basically what we can do is, let me kind of show you a little side note on this and we'll kind of bring it back in. That if you had, and this is more of a side note from the graph of what we got from this one, so this just kind of put this off on the side, but when they talk about interval notation, it really kind of goes back to when you're graphing inequalities. And it's really just a different way of showing the numbers you would have from a less than and greater than, but instead of giving you x less than 2, they put it using just some numbers here. So if you had a graph, let's say that you were graphing, some number line that was like this, and let's say we were starting at -2. So we had x was less than -2. That when they talk about interval notation, that basically they're saying, all right, tell me you got to cap it off by 2 numbers. Tell me what's the lowest number you can use on that graph. Tell me what the highest number is that's on that graph. So interval notation basically is going to take a graph that you have like this and says, okay, here's my lowest number. This thing's going to go all the way down to -infinity. We're going to get up to -2. And with interval notation basically is this: if it's an open circle, when we do interval notation, that's going to be parentheses. And if you have a solid circle, that's when you're going to use a square bracket. Now, infinity or -infinity is exception to that one, because infinity, you never can put a cap on it. If you give me a number, I can tell you to add 1 to it and it keeps going. So infinity is one of those numbers that you always use an open circle with either negative or positive infinity, because there's not an ending point. Because basically the square bracket, when you have that one, says, all right, that's a cutoff line. That's the max you can get. You cannot go any beyond that. This one says, well, you can get close to it, but you can't quite get there. Infinity, you can give me a billion numbers, and then you give me a billion and 1, billion and 2, billion, you can just keep adding to that one. So infinity or -infinity, you're always going to use the open circle when you go through those.
Solid circle, like at -2, and open circles like -2, up until -2.
If you had this one, let's say that was at 4. If they ask you, inequality-wise, that would be x greater than or equal to 4 in interval notation. So this would be your answer in interval notation here. Interval notation says, all right, the lowest number that's on this graph is at 4. It's a solid circle, so basically you put the square bracket around it. This thing's going to chase to infinity. And again, infinity is always going to use the parentheses when you go for that part. So it's just a way of saying, tell me what the leftmost number is that's on the graph, and then tell me what's the rightmost number that's on that graph. And you're basically basing off of those 2 values, so that you've got, it's a maximum and minimum point. That's the lowest point on the graph, that's the highest point on the graph. And that's the whole thing of interval notation. It's just a different way of showing this kind of graph where you give me a max and min numbers on this thing. That's, to me, the best way of saying exactly what interval notation is on this part. Okay, now here's what they tie in back to the max and min, or sorry, the increasing and decreasing part. Is they're just going to give you a graph that's here, and they're going to say, all right, tell me where it's increasing, tell me where it's decreasing, and tell me where it's constant. And they start you off with just a basic quadratic of one like this. And they'll just say, all right, here's a graph. Tell me where it's increasing, tell me where it's decreasing, tell me where it's constant. And, of course, we've got to give you something here to go with it. Okay, we'll do that one where it's just a basic quadratic, starting at 0, 0. Okay, the biggest thing on those is you have to, when you describe it, you have to describe those using only the x values. I'm sorry. Yeah, we'll get it here in just a second. So I didn't give you any specific. I mean, we don't need specific values in this one, but okay, increasing wise. Well, the graph is going up. If we start at 0, 0, it's headed this way. So again, you're only looking side to side. So you're starting at 0, you're going to infinity. Now, 0, this is one of those where on these graphs, you don't really know what it's doing at 0 because they call it an inflection point, or everybody's got a different way that they call it. So if you do 0 for this part, that's one where they should just do an open circle. I mean, parentheses for that one, because you don't really know exactly what it's doing at 0 because it's a transition point. It's going from being decreasing here, now it's increasing. It's kind of that point where it's not really doing anything at 0, but we're going from 0 to infinity, so that would be the increasing part.
So it's the parentheses in front of 0 because it could go to infinity on the other side.
Well, anytime you go infinity, it's always parentheses because you don't know what 0 is doing at that point, because it's kind of that gap where it's in the middle of increasing and decreasing. You don't know what it's doing, so that's one of those where if you can tell exactly what it's doing there, you might could put a bracket on it. But one like this, you don't really know what the 0 is going to do, so it's kind of like, you know how 0 is not negative, it's not positive, it's just nothing. This one's kind of the same way. It's not increasing, it's not decreasing, it's just kind of that gap in the middle to say, okay, we've switched from increasing to decreasing, so at that point it's not really doing anything, it's just there, kind of like a placeholder almost. The decreasing part, well, that would be from negative infinity to 0. And then the constant, well, then there should be none there. All right, so let's give you one here where it's a little bit different. A little different look, but along the same lines here. Okay, and for these, you'd have to be able, of course they give you grid lines on this one, so I'll go ahead and give you the points here. This would be at negative 3, 2. This point would be at 8, 2. And as far as points go, that's really the only points you would need. Okay, and we'll do the same thing. We need the increasing, we need the decreasing, and then we need the constant part. Yeah, the increasing, decreasing, and constant. Okay, so here's your part of it where this is the part where the graph is rising from the left to the right. So that one, it's increasing from negative infinity. And again, when you're going through these, you only describe the x value, so the 2 doesn't really come in impact. This one, you're getting a negative 3. And then it changes here, and now we're going horizontal. So that would really be the no change. So that's negative 3 to 8. And then the decreasing would be, what's that? Because it's horizontal. Yeah, there's no change. There's no up or down movement to that one. And your decreasing, that would be from 8 down to infinity. That one, because on that particular part of the graph, we're headed this way. Now, it's going down on the y value, but x value was happening. Because that's, so again, you're not really worried about that part. This one starts at 8, 9, 10, 11, 12, 13, 14. So as you move farther out here, the x value just keeps increasing. So you've got to, yeah, you got to ignore the y. Even though it's going down, you've got to ignore the down part and realize, okay, what's it doing as I move to the right? That number just keep getting bigger, so that's why it's going infinity there. That's, to me, that's the hardest part, is forgetting the up and down movement, and you got to look at just the side-to-side movement when you describe it. So, okay. Now, I think the only time on these where you would actually get something on here where you would use square brackets would be something like this, where there's no arrows on the end of these, where you've got a definite ending point and a definite beginning point.
Couldn't use it on B, like from the 8.
Come on, like at those 2 points right there.
Or yeah, like
Well,
B, you could use the square bracket. Like a definite starting point, 8, increasing point.
well, and this is where it's that transition point, because on this part of the line it's horizontal, right? But as soon as you get here, now it's from here to here it's horizontal, but from here down it's decreasing. So it's kind of both at that point. So 8's kind of that, it's still that transition point that if it's changing from positive to negative, you can't say that point's either one, because it's, you know, for this part of the graph it's decreasing, but on this part of the graph it's constant. So it can't be both at the same time, so that's one you just have to chunk it out and say, okay, it's neither one of them. It's kind of like midnight. Is that AM or PM?
So, like,
You know,
so when in doubt, just go with the parentheses.
yeah.
Unless it's like explicitly obvious.
Yeah, unless it's like this, where there's a definite starting and a definite ending, then it's going to be parentheses more likely. So, okay, and for this one, oh, let's see, this would be at -5, 3, and this would be, let's say, at 5, -2. Okay, so there's no infinity on this one. There's a definite ending point, a definite beginning. There's no transition. There's not part of it. It's the whole graph is decreasing. So for that one, what's that? C would be none, because there's nothing horizontal there. There's nothing increasing, so that A part's also going to be none. And for this one, because there's a definite starting and there's no transition points, this is one where it should go square bracket -5 and then +5. Because, you know, there's no if, ands, or buts. That one, that's a definite start and stopping point. If they wanted to open parentheses on those, they would have put a circle like that. That way you would use a parentheses there, but because those are definite starting and ending points, then those you can use a square brackets on. Okay, so that one, again, I think that's more of a, it is increasing, decreasing, and constant, but they also throw in the interval notation, which, again, they didn't really talk about it. They just kind of sneak that in and just assume that you know what's going on, and sometimes people don't. So that's why I'm going to go back and try to pick those up there. Okay, after they've gone through and done the increasing, decreasing, constant on these, they switch gears and they talk about functions being odd, being even, or neither. And with that one, they tie in that basically, if you have these, when you, based on what you have here, your symmetry, if it's an odd function, for that one, you're going to have symmetry with respect to the y-axis. If it's even, you're going to have symmetry with respect to the origin. And if it's neither, Well, then it has none because there's nothing that's going on with that part of it. Okay, and this is one of those things where they try to make it a lot more complicated than what it is, but basically is this. If it's an odd function, all the exponents are odd. If it's an even function, all the exponents are even, and if it's a neither function, then it's a mix of even and odds. So they try, now they go through, and again, their blah, blah, blah definition, it gives a lot more than that. But again, it's odd, meaning that if it's an odd, all the exponents are odd. If it's even, all the exponents are even. And neither means it's got odd and even exponents. Okay, and if you go back and look at the definition, they try to give it a lot more technical definition, and technically it is a lot more than that, but when you break it down to it, that's all it is. Odd, it's all odd exponents. Even, it's all even. And if it's neither, it's neither. And they're going to basically tie that in, that if it's odd, then again, you're having y-axis symmetry. If it's even, you got symmetry with respect to the origin as you go through these. And they'll just give you some examples. And they'll ask you, okay, here's a function. Tell me if it's odd, even, or neither. And then tell me what, says then determine whether the graph's function is symmetric with respect to the y-axis, the origin, or neither. So again, it all ties together when you do this one. This one, you got x to the third. Now here's where sometimes again you have to make sure you get the little bits in there. This is x, but technically it's x to the first. So you've got 3 and 1. So it's an odd exponent. Everything's odd, so it's an odd function. And if it's an odd function, it automatically has symmetry with respect to the y-axis. Okay, you've got 3x squared minus 6x to the fourth. Again, you're only looking at the exponents. They're both even, so it's an even function. And if it's even, that means it has symmetry with respect to the origin. So I think this is one of those. They should give you a drop-down menu that's got y-axis, origin, or none. So then your symmetry will basically say it's origin symmetry. Technically, you're supposed to say symmetry with respect to the origin, but just, faster to say origin symmetry. Okay, if you've got 6x squared plus 3x, you've got x squared, x to the first. If it's a mix, then it's going to be neither. And again, if it doesn't have any, if it's a neither option, then there's neither on. It's neither on both of them. If it's a neither function, if it's not odd, it's not even, that it doesn't have any symmetry at all. Okay, and again, now they'll come back later on and they'll ask you to do some things, and sometimes people overthink it. I'm like, oh no, just, when we get, because we'll key on that now, we'll come back in section 7 and they'll ask you to talk about the symmetry. And you just got to realize, okay, all I got to do is look at the exponents, and that tells me what kind of symmetry I've got. So it's one of those things, just kind of put it back in memory, and we'll pull it back up in a couple of sections and talk about everything that's there. Okay, and the next thing they'll talk about is a piecewise function. And with it, there's not with all the other functions, there was just one function. You had one graph. That was pretty much about it. A piecewise function is what it sounds like. It's made up of pieces. That it's got 2, maybe 3 different pieces that make this thing out to be a function. And it should look something like this when you go through these. That instead of it just being one function, they'll have you a bracket here with some different parts on it. And then they'll have you kind of fill in the blanks on these. Okay, so for this one, we'll stick with 2 pieces. Now, when you get the 2 pieces, they have to give you a cutoff, because basically they're saying that for everything on this part of the graph, you use this, and for everything else on the other part of the graph, you're going to do this one. So for this one, they're going to use basically 0 as the cutoff. Anything less than 0, you're going to use this graph. Anything that's 0 or greater, then you're going to use this part of the graph. That's an if, yes. That's a terrible if, but that's an if. Okay. Okay, let me get this one, because this is, anytime we've done the paper pencil, this is the one thing that people always miss. Even though it's a piecewise function, you still only give me one answer. It's kind of those rules of, okay, if it's after 5 o'clock, call me at this phone. If it's before 5 o'clock, you got to call me at this phone, right? And this is basically this thing. It's saying, all right, if it's 4:45, which one are you going to do? Well, I'm going to call this phone because it's before 5 o'clock. It's kind of the same thing on this one. So what they're going to ask you to do is they're going to ask you to find or evaluate, and then they'll give you 2 or 3 different numbers. Now, they give it to you one piece at a time. So they'll tell you, all right, evaluate f of 3. So in that case, you're using x equals 3. And if you're using x equals 3, 3 is definitely greater than 0. So that means we're in here. So we're going to take that 3 and plug it into this part of the function. So f of 3 would be 4 times 3 plus 7. So that's 12 plus 7, that would be 19. Okay, so again, even though, because this is still going back to the definition of what a function is. A function is, if you give me one number, I'm going to give you one answer. Still the same thing this one, because I'll get people that they'll give me one number and they'll say, well, it's this answer or it's this answer. I'm like, no, because the main definition of a function is you give me one number, you tell me one answer. Even though it's a piecewise function, it's got 2 different parts. The value they give to you can only fit in one of the 2 parts, and you've got to figure out, does it fit in this part or this part? And that's where it's going to go. There you go. And that was my next. You stealing my thunder there. So that was f of negative 3. Okay, so for that one, we're using x equals negative 3. And negative 3 is definitely less than 0. I cannot draw today. Whatever that was. There we go. So negative 3 is less than 0. So that means for that particular one, we're definitely in there. So we're going to use the 3x plus 5. So when we do f of negative 3, it's going to be 3 times negative 3 plus 5. So that's negative 9 plus 5. And there's your negative 4. Yeah. Yeah, we'll give you that one right there. We'll do that one next. Okay, and that's usually what they'll do. They'll give you one that's obvious positive, what they give, and then they'll throw in a third one and say, okay, now what happens if it's on the borderline? And for that one, you got to figure out, okay, if it's on the border, there's one part of it because this one was less than, this one was greater than, but here's the key thing on that one. You got the equal to part, right? That equal to part means if it's ever that number, you've got to use that particular one right there. So we're going to have to use 4x plus 7. And they should always give it where one of them's going to be, only one of those should have an equal part on that one, so you know which one it fits into. Okay, so, and that's what piecewise functions are just that. And again, if you will just get the thing going in your head that all I got to do is give me one answer, you're good to go. Just figure out which part of the answer it fits into. Now, they'll give you all kinds of different functions, have you do all kinds of different things, but it still comes down to, okay, here's the value I get. Does it fit in this piece or this piece? Or maybe there's a third piece, and you just figure out which of the three it fits into. But it's still a function, so if you give me one answer or one number to plug in, you still only give me one answer back. Okay, and then the last thing you got to do, and this is probably, I'd say this is probably the toughest thing. It's in chapter 1. And there's one easy question and there's one hard question. This is the difference quotient. And it's got one formula that's got two parts, well, really it's three parts to it. Okay, so that is your formula, yeah. Yeah, that's not a question. No, that's your formula. Okay, so anytime you're doing the difference quotient on these, you got to use this formula and go through it. Now, and here's basically what it is. You've got to do a couple of different things with this. The very first thing you've got to do is you've got to evaluate f of x plus h. Okay, now that's really the only part you really actually have to do is that one, because you're going to be given f of x, so that part's there. The h is already here, and once you do that, you plug in the f of x plus h, and then you plug in the f of x, and then you simplify. But there's a lot of work that goes in between those. And depending on the problem they give to you, some of the problems, finding f of x plus h is really easy. When it gets a little bit more complicated problem, then it gets a little bit harder to find the f of x plus h. But we'll give you two. There's basically, they give you one easy one and they give you one hard one. We'll do both of them here, so you can at least see what they look like.
Quick question.
Go for it.
What is h?
H is just a variable that's in there. Now, and basically what it is when you do the difference quotient, the h's cancel each other out, and that h is in there so that at the end the h's cancel each other out and it just leaves you with an answer that's just got x in the answer. That's really what it comes down to. When you get to calculus, they give you a shortcut for this thing, but they make you work hard to get through it so that you do this enough and you got it in your brain, you got it memorized in your brain, and then they go, okay, well, here's the shortcut, and they go, really? That's it? That's all I do? And like, well, yes, but technically you're supposed to do this, but they wait and give you the shortcut then. They make you suffer for a while, and then, they come back and do this part. So, exactly, yeah, they make you earn it. So, all right, so here we go. Part A is you've got to evaluate. You've got to find, I don't know if find is the best word. You go, oh, there it is. No, you don't have to, you got to do more than that. Okay, so we got to figure out what f of x plus h is. which means all we're going to do up here is wherever you have the x, you're going to take x out and plug in x plus h. So that's going to be 3 times x plus h plus 7. Okay, and again, if it's just x to the first power, this is really not bad because all you're going to do is a little bit of distributive property. That makes it 3x. Oops, right here, change the colors back here. It's 3x plus 3h plus 7. Okay, so as far as like actually doing work, that's the hardest thing you have to do. Everything else from there, you're just going to combine like terms. So, and you may want to put that back here. When we're simplifying, we're just combining like terms. Because once you've done the part A where you're evaluating and figuring out what the f of x plus h is, the f of x is given, the h is given, everything else from there is just formula, so you're just going to combine like terms. Okay, so we got part A, so now the part B is you're going to plug everything in. Okay, so we had f of x plus h, so that's going to be the 3x plus 3h plus 7. And then it's minus the f of x. Now, the key thing on that is when you do minus f of x, it's got to be minus the whole thing, which was back here, which was the 3x plus 7. And that's over h. All right, so from there, you've got, and again, all we got to really do is do distributive property back here. You got 3x plus 3h plus 7. We're going to do minus 3x, and we're also going to do minus the 7. And that's over h. Okay, and right here, you have 3x minus 3x, so those two knock each other out. You've got a plus 7 and a minus 7. Those two knock each other out. So that will leave you with 3h over h. H's knock each other out. Leaves you with 3. Okay, now and here's basically what, and I'll kind of go ahead and say this one, I don't know if I should or not, but as long as it's just x to the first power, when you get to the end, it should be just a number. When we do the harder one, when you go up to x squared or x to the third or something like that, then you're going to have more than just that number that's in there when you're going through those. But that's the easy one. That's where you got x to the first power. X to the first power is a lot easier as you're going through this one because the f of x plus h part is always pretty simple. It's pretty straightforward. When you get the next example that we'll do, this will be the last one we'll do out of section 3. When you bump that thing up just to 1 power here, it gets a good bit more difficult. So we've got x squared minus 4x plus 3. Okay, and first step's still going to be the same thing. You've got to evaluate the f of x plus h. So everywhere back here that we had x, we're going to take that part out and we're going to take the x out and replace it with x plus h squared. So we've got x plus h squared minus 4 times, we'll put the x plus h here, plus 3. So everywhere we had x, we're taking the x out, replace it with x plus h. Now here's what makes this one a little bit more difficult. Because this part, if this wasn't here, we're good to go, right? A little distributed property, we add the 3, we've got what we need. But with that part being there, it gets a little tougher because this is the part that you have to do, yep, gotta do the full method on it. So we're going to do x plus h times x plus h. Now, here's the good thing when you do this one. That's terrible again. Once I do this for you, and you get this problem in the homework, you don't have to reinvent the wheel on this one. That anytime you do x plus h squared, you can kind of just look back in your notes and go, okay, Mr. Richardson told me that anytime I do that one, I don't have to reinvent the wheel. I can just look at this and the answer will be the same every time. Absolutely, this part of it will be the same. Now, the back part back here will change, but anytime you do x plus h squared, that anytime you start off with x squared, that very first step of this one, when you do the full method, it's always going to be the same thing. Because you're going to have x times x for x squared. You're going to have h times x for 1xh. You're going to do another one here, so you're going to have 2xh's. And you're going to have h times h for h squared. So that part will be the same every single time. Now behind that, that part will change a little bit depending on the numbers. This one is negative 4 times x, and then negative 4 times h, and then we've got the plus 3. And technically, we don't really have to have those parentheses here because they don't really do anything. Okay, and that whole big ugly thing is f of x plus h, yeah. Again, just by going up to x squared, we went from a really easy f of x plus h, now we got this big long one, which makes it, when we plug it back in, it makes it a little bit tougher. So now we're going to do the same thing. We're going to plug in the f of x plus h and f of x. So once we plug it back in, I'll tell you what I'm going to have to do. I'm at the bottom of the page here, so let me go to a new page. We're going to plug in f of x plus h and f of x. Let's see if I can remember that one when I go to the next page here. Okay, so we've got x squared plus 2xh plus h squared minus, y'all help me out, 4x, was it minus 4h? There. Plus 3. Okay, so that's the f of x plus h. That's the whole thing that's there. Then we've got to do minus f of x, which was x squared minus 4x plus 3. And that's over h. Okay, now here's the catch with these. And anytime you're doing these, it's always going to be the same thing. Anything that doesn't have an h will combine like terms, it's going to go away. That when you do this one, before we just start canceling, we've got x squared plus 2xh plus h squared minus 4x minus 4h plus 3, and we've got to change all the signs in the f of x. So it's a minus x squared, a plus 4x, and a minus 3. And all that's over h. Okay, and the only good news that comes from this one is that whenever you do the difference quotient, anything that doesn't have an h goes away. That may not be a whole lot of good news, but that's the best news you can get from this one. Here's your x squared term. There's another x squared term that's a minus, so that one goes away. You've got a minus 4x here and a plus 4x here. You've got a plus 3 here and a minus 3 here. So you're left with everything that has just the h terms. So you have a 2xh plus h squared minus 4h. Okay, everything else is gone. That's over h. Now, and what they want you to realize is in the top part, they all have an h in common, so you can take the h out. You can get the h out of there, right? And by doing that one, those h's will cancel and leave you with 2x. Most of the time, if you get an answer like this, where you put the terms, it doesn't matter. But when you get into calculus later on, they'll tell you it's 2x minus 4. That h value that's stuck there, because it's something we just kind of threw at you, this new that's in there, they usually stick that at the end just because it's not really always a part of what we're doing. So go for it.